like to introduce Dr. Manohar Swaminathan and Professor Amit. Dr. Manohar Swaminathan is currently a principal researcher at Microsoft Research. His primary research interests include virtual and augmented reality technologies. Currently, he is focused on applying these for empowering visually impaired persons. His other interest is in the use of IoT and cloud for large scale impact in emerging markets. Dr. Amit Prakash is Associate Professor and Convener of IIIT-Bangalore Center for Accessibility in the Global South. The focus of his recent research and outreach efforts has been in equity and inclusion on matters related to technology design and policy choices. He is also a founding trustee of Vision Empire and a director at Wemby Technologies in Itihasa Research and Digital. I request Professor Amit and Dr. Manohar to take over the session. Once again, a very warm welcome to everyone. Thank you.
Over to you, Dr. Manohar. I think
Yes,
there's no need to introduce me here. Sorry.
Yeah, sure. So let me just get started. Welcome everyone to this session on AT in the Global South. Pleasure to have Sylvia here as well as Vidya, our other speaker. And so what I want to do is give a quick introduction to AT in the Global South. The idea behind this session is this is a fantastic time for assistive technology globally. There is a huge convergence of IoT, low-cost smartphones, low-cost sensors, devices, cloud, AI, ML, and so on and so forth. There's an explosion of technology solutions for people with disabilities. However, many of them may not be appropriate for the Global South. And it is not just about low-cost AT. There is a whole host of solutions host of characteristics of the Global South that prevent these solutions being used by people with disabilities. And it should also be noted that 80% of the people with disabilities are reported to be living in the Global South. And so what is required is creation of solutions for people with disabilities that take into account the lived experiences of people with disabilities in these geographies, in these areas. And of course, as we see in this conference, in India, there's a tremendous amount of innovation in the technologies for people with disabilities. And the ecosystem is very, very growing and energetic, as we see in the product demos, and there are incubators and accelerators for technology startups in this space. So there is a large amount of energy and enthusiasm and creativity in this space. However, one of the major constraints in any of these technology solutions, especially for people with disabilities, is that it's often viewed as it is a very niche market. The number of units of sale for a given solution is limited if we are going to look at India as a market. India is a large country. There's a large number of people with disabilities who need these solutions. However, the complications of the Global South is that the end users are most likely not the purchasers. There are government agencies, charitable organizations which come in, which procure these solutions and then hand it over to the end users. And most of the time, the gap between an innovative product in the prototype stage and the market is extremely large. So one of the things that we could do is to explore adjacencies, to understand Global South beyond India, what kind of similar experiences are there, and how we could create partnerships between organizations that are working with people with disabilities there, innovators in all of these other areas that are creating solutions, and how we can build partnerships and collaborations between the South and South. So for example, recently I was part of a panel to judge startups in accessibility in Africa. And I saw very similar kind of presentations in terms of the need, in terms of the mismatch between the existing solutions and the current needs in those local environments, and how innovations have to be tailored to the local needs as well as the ability to be manufactured, serviced, and supported locally. So there is very many similarities between what we hear in presentations that we hear here, the solutions that we create here, and the ones that were presented by startups in Africa. And I'm pretty sure that similar things are happening in, for example, Mexico, Brazil, and so on. And so one of the objectives of the session is to start this conversation for this community of Empower to build bridges with other innovators working in the area of accessibility and technologies for accessibility. And so what we will do is, in this session, we will have two speakers. First is Vidya. I will introduce her shortly, who will talk about inclusive education in India for children with vision impairments, her personal experience, as well as her role as the co-founder of Vision Empower Trust. And we have Professor Sylvia from University of Mexico, who has joined us. She will talk about the broad use of AT in Mexico. After which we have two short papers that are a part of the session. So I suggest that we will have questions after each inviter speaker, as well as after Sylvia's presentation. We will have a sort of a panel discussion where we can have open-ended questions about possible areas of overlap, collaborations, etc., and so forth. So let me first invite Vidya. Vidya, are you there? While yes, so hello Vidya. Let me briefly introduce Vidya. All of you who would have seen Vidya in our beautiful singing at the invocation at the beginning of the conference. So Vidya is a co-founder of Vision Empower Trust, disabled people's organization located in Bangalore and incubated from IIIT-Bangalore. She also personally, I have interacted with Vidya in many capacities, first as an intern at Microsoft Research, then for 2 years as a research fellow, but more productively as the co-founder of Vision Empower Trust, where we have been doing very interesting work, some of which she may touch upon. Briefly about Vidya, she had to cross many, many barriers, some of which she will talk about in her talk, but she successfully reached the stage where she was one of the early students at the MSc Digital Societies program at IIIT-Bangalore. She topped the class, and she has deep passion for enabling STEM education for children with vision impairments in the country. And so she will share her views and perspectives on inclusive education. Over to you, Vidya.
Thank you, Manohar, for the introduction. So I hope I'm audible and you can see me. So firstly, my gratitude to Empower team for having me here. And I'm really happy to be sharing my experiences and my observations as a person with visual impairments from an Indian perspective because I live in India. I have been on both sides where there were no accommodations at all, and also I've seen how everything has improved when necessary accommodations were provided for me. And this has helped me understand ground realities better because I've been there. And now that I have the privilege to voice out my views and work in this area, I'll be sharing only what I've experienced myself with regard to education. And also, I'll be sharing a little bit on what changes I have observed from my school days till now. And also, um, I'll be sharing what more could be done to take our collective efforts forward. So these are just my lived experiences and observations, and I haven't borrowed them from existing literature. So I'll just start with my experiences now so that you know my background, and then I will be able to take it forward from there. So I am visually impaired since birth, and I was born in a village And in the Indian scenario, we all know the situation, what happens in villages. So people are not educated. At least in my village, we didn't have people who had gone to college. And there's huge stigma about disabilities. Even now it's there, not much has changed. Like when I go to social gathering, people generally ask me one question, right? Like, who am I? At least 15-20 people will ask me, and I say, okay, I don't remember. Or how sad it is to see you like this. So they just view disability as something unfortunate. And one more thing is there were no resources that were available when I was born. And the awareness was not there, because first time everyone was seeing a child with visual impairment. And naturally, first 4 years for me went in trying to restore my eyesight, with the hope that I'll be able to see again. And that was the step any parent will surely uh, take. So the first ray of hope came from the doctor, who from the ophthalmologist, and she told my parents that give her good education now that nothing can be done about the eyesight. So this is when my parents started even thinking about educating me, and that was a ray of hope for them. And second major turning point was once one of my neighbors started following a vehicle, and for 15 kilometers he did that. I'm not sure why he did that, but it took him to one of the charitable institutions for people with and without disabilities. And fortunately for me, over there only one person knew Braille, and that's where my introduction to Braille started. And in this center, it was a vocational training center, it was not the school. So they insisted that I study in a blind school in a formal education kind of setting. And then I went to a blind school, and I stayed there in the hostel because it was really far from my village. And in my school, I started realizing that I really enjoyed math and science. At those days, I was not aware of, okay, something is not accessible to me and something's accessible to me. But math was surely my favorite subject. Even when I was a child, I would count the number of mustard seeds. I would count rice, how much rice I'm eating. I just count the number of rice. Or I would count the number of oranges that are there. Everything that I found, I just went on counting, is what my mom says. Even I remember slightly. And in the blind school, the typical trend was that everyone kept telling us, okay, you finish seventh grade and naturally you'll take up humanities, because that's what majority of the blind students were doing. I'll come to why this is so a little later. But I really loved math and science, and I shifted to a regular school. By then, we had shifted to a town for my eighth grade. And in eighth grade, the challenges actually started. Uh, Everything was done on Blackboard, and I couldn't follow because someone says this multiplied by this is 20. I have no idea what the teacher did. And there were no books. There some books were there in Braille, but it had only theoretical content. So digestive system was just the theoretical description without knowing what the diagram looks like. And you can't study math and science just with this kind of an approach without diagrams. So teachers did not know also how to teach me, because they were seeing a blind child for the first time. And naturally they don't know how to explain trigonometry or how to explain geometry to me, what tools are available back then. Even I did not know. And technologies were there, but some of them I couldn't afford, and others were there, but I was not aware that they were there. So I could not use any technology at that stage. And I'm not going to go into details of what challenges were there in college, but the same challenges continued. And I wanted to study science, so I took up computer science. It was like fairly new, a visually impaired person trying it out in India. It was a little new for my graduation. And so I didn't have many people to rely on, especially in the visually impaired community, who had done this before. And huge problems were there. And the software that was used also was not accessible. So all of these continued, but I stuck on to technology related subjects till my post graduation. And now I am so after my post graduation, when I was working with Manohar uh, at Microsoft Research as an intern. After that, so me and Professor Amit and Supriya from IIIT, we co-founded an organization called Vision Empire in 2017. And because my expertise was in this area, I wanted to see if we can contribute some way in to this area, because it was always my passion. I thought about it, but I never knew that this will come to reality so soon. So at Vision Empire, I'll just mention briefly what we do, because I've already touched upon what the problems are. So uh, first year, we actually conducted research to see if all the problems that I went through are still existing or not. And we found that nothing had changed. Literally nothing had changed. Everything was the same. And so here we are focusing on holistic approach, not just one. Technology doesn't solve everything, so we are focusing on holistic solution. Firstly, we make all the content including diagrams accessible, because as I told you, content was access to content was always a challenge. And we train the teachers on using our solution, and on whatever gaps they may have. We also work with Microsoft Research on computational thinking. It's really an area which has started gaining momentum now, so we are starting early on. And in computational thinking, we design games for children, and children learn computational thinking through play. And this is like really popular. These games are really popular among the children we work with. And we also have a host of technologies and research, and IIIT has been a huge support for us. Research and everything happens at IIIT Bangalore. So now these are my experiences, and I wanted to mention what changes I have seen from the days when I was in school to now. So I finished my 12th grade in 2011. So before that and now, what changes are there? So what I have seen from working in the field, I'm going to touch upon them a little bit. Actually, there are huge changes, huge. So I'm going to focus on changes in the educational system, not only on technologies, because as I mentioned, just one technology doesn't solve the whole problem unless social context in which it is used is also taken care of. So firstly, the parental involvement with children has increased a lot, and that's a huge step, because now we see at least the children whom we are working with across different states, parents are involved with the students. So when I was studying, most of the blind children in my school and in other schools would go home only once in 1 year or twice, many of the children. But now it's no more the case. A lot of children go home on daily, and many, even if they cannot, if they stay far, at least parents keep in touch with the children. So that is huge. And thanks to improved medical care, number of blind children have reduced in a big way. uh, so we were starting early childhood program, and we had reached out to government departments and some of the hospitals, and everyone told us the same thing, that these days there are um, the number of blind children have reduced because majority of them were preventable, and they were not being prevented, say, a decade and a half back. And so these days there are very few children who are being detected with visual impairments. Very few, as in it has considerably reduced from the time I was in school. And so before the priority, before as I was mentioning, even when I was in school, some parents were very much involved with the students, but a lot of time would go in just getting the materials into accessible format. But now that OCR and other technologies have improved significantly, we see a lot of parents interested in the holistic growth of children. we also see a lot of children interested in cycling. Some of them are exploring art. Some of them are exploring everything that their siblings do. They're trying out a lot of new things, and this is really good. And also, the parental involvement for children with multiple disabilities also has increased. At least in when I was in school, I would see a lot of these children just being left out and being abandoned by their parents. But now, a lot of effort from the parents is there. Recently, I was conducting a quiz, and some of the sessions I was involved in. At least in every session, we have one child who has other disabilities as well, but their parents are also involved very much in their education. And technology progress, I don't even have to talk about it. It has improved very much. Children as young as 6 years know what Alexa is. They're able to get onto calls by themselves. And when we started our digital literacy intervention, I could not even believe that even in the remotest part of the country, teachers were able to have internet connection. They were able to connect to Zoom. I thought in villages, nothing much can be done, but this is really not the case. And technology access also has improved in a big way. And also, role models among the disabled community has increased. People are trying out new things, and for the younger generation, they have somebody to look forward to. And um, these parents, some of these parents are also in touch with some of the people with disabilities who have been successful. And now a lot of organizations have been thinking of making STEM, science, technology, engineering, and math accessible to children with visual impairments. At least when I was a child, I knew only one or two organizations in the country thinking about it. But now so many people are thinking about it. And I'm sure if all of us work together in 5 or 10 years, we can see huge changes. And I also see a lot of mindset changes uh, in among teachers and also in the society. When I was studying, as I mentioned, taking up humanities was the norm, whether you like it or not. But now teachers are really positive. They know that even visually impaired students can study these subjects, and even the children themselves know. So I wanted to also mention a little bit about what I feel can be improved. Again, these are just my perspectives. Um, So I feel that still a lot of the organizations are working in silos. There is some kind of collaborative effort. For example, when we take Sugamya Pustakalaya or Bookshare, so we have all the books available in a single place, which is really good. And we need the same kind of approach to make STEM education accessible, because we know it's not very easy, and we need so many people to come together to work in this area and make the whole education system accessible. And I also feel that somehow we have ended up copying, concept of accessibility and independence from the West, and we are trying to implement it here in India, and sometimes it is not working. So uh, yesterday, I think someone was presenting that in India, though visually impaired people take help from other people, and they still feel independent, because um, in India, everyone is interdependent, and we see people hanging out together, people traveling together. But that concept may be very much different in the West, the concept of independence. So while designing any technology solution, we really need to consider these views as well. And um, and also, I often feel that everyone is talking about making each and everything accessible, but sometimes I feel that we also need to consider whether making it accessible makes any sense, or does it have relevance. For example, once when we were making a math textbook accessible, so we were trying to make the place value concept accessible. So suppose we take the number 12, so we have to explain the concept of place value with the number 12. So in a regular textbook, there were say 2 apples in the place of units, and that is to explain that 2 is in the units place, and say 1 banana which was in the tens place. The children who can see had to see these and identify how many are there, and just to know the concept of place value. So when we copied the same thing, what happened is our children who are visually impaired were taking lot of time just to figure out the shapes. So suppose you have 8 or 9 in one box, then you 8 or 9 in a square, 8 or 9 apples or bananas. It takes really lot of time to even identify the shapes. So we realized that instead of putting 2 apples, we just put 2 dots. It's so easy. You just touch and you know how many dots are there. The concept makes all the difference here, and not the apples or bananas or whatever shapes you are putting inside the square to explain. So it doesn't literally mean that you have to make each and everything accessible. It also sometimes depends on the context and the relevance. And the same thing applies to, we have this very strong concept that each and everything that say a blind person, a sighted person does, even a blind person has to do. I really feel sometimes that also is context dependent. Because for example, suppose there's only 5 minutes left and I need to quickly finish my food, because all the sighted people are using cutlery to eat the food. I just don't have to do the same thing, because there's no time within. I figure out it's taking too much time, so I'd rather eat the food with my fingers. So I feel even that concept is sometimes context dependent, and we need to inculcate some of those perspectives. Even in the disability community, we have diverse views which needs to be considered. And we really need more and more and more affordable technologies. That is really need of the hour. Because now, for example, all the children in the schools that we work with are using something called a tailor frame for doing their math. I'm sure all the children love it, but I'm sure there can be many more better technologies that are much easy to use, and a lot of organizations, as I was mentioning, should come forward to design these technologies which are really affordable. And we need many more technologies in say areas like making your science lab accessible, or making the experiments that are there accessible. For all of these, we need many more technologies, and that will simply make lives of various people with disabilities much easier. And also, I really feel that aspirations, kindling aspiration among the children is very much needed. Because once I went to a 10th grade class and asked students, what do you want to be when you grow up? Because these children have aspirations. And then all of them were mentioning that they wanted to become IAS officers, because now they're seeing a lot of visually impaired people in these fields. So one day, maybe 5 or 10 years down the line, they'll have to at least feel that they can also become engineers, doctors, if they want to. Again, it's not a compulsion, but at least those who want to, they should at least have the aspiration that they can do it. And bringing children to conferences like these, asking their views on what they want, actually helping them meet people who have succeeded, I think that is really important for the children and their families. And one last thing I wanted to mention is, somehow I feel still there is a kind of charitable mindset within the community, and also within people who are providing these solutions. I'm sure that affordability is always an issue, but I feel that even if some families can pay a little nominal, can pay nominal, say, price for some product or service you offer. So what happens is it's just ingrained into the system that everything is given for free, and that really I feel sometimes it reduces the self-esteem of the people who are buying it. And also it doesn't encourage a lot of people to come and work in this area. Just they know that okay, everything has to be done for free, and somewhere you have to take care of your needs and your family needs also. So I feel somewhere we need to change this, and because a lot of parents buy a lot of products and solutions for the children who can see, or for their non-disabled children, and that same thing should be encouraged for the people with disabilities. So these are some of the changes I really wish to see. Thank you so much.
Thank you, Vidya. I have one question before I have questions from the audience. One is your experience when the pandemic struck. I'm familiar with the shock that we all had because most of our work was in person. And so could you just touch upon the work that you had to do to reach out to teachers during the pandemic, getting them online, etc. That will be very useful for the audience here.
Yeah, so the pandemic was really, we had to think out of the box, because till the pandemic, we assumed, and it was true also, that for a blind child, or even if we want to work with a teacher who is visually impaired, touch and feel is really important. And without touch and feel, you cannot do much. And when it's all to be done in online setup, so the whole concept of touch and feel is not there. So how would you explain a diagram, and how would you even train the teachers? That was a big question. So the team at Vision Empire, we all brainstormed our ideas, and we thought, okay, we will be starting off with Zoom and other online platforms, and we'll be reaching out to teachers and taking it forward from there. But when we reached out to the teachers, we figured out that most of the teachers were not even using technologies. Some of them were using technologies, but somewhere they were in the intermediate category, and a lot of them were in beginner category. And very few teachers were in the advanced level where they knew technologies. So we had to come up with tutorials in different languages on using various applications. So we had one on Google Meet, we had one on Be My Eyes. I think Be My Eyes, most of the people here know what is Be My Eyes. It is an app which connects a volunteer with a blind person to seek, to avail assistance online. So these apps we felt will be very useful for the teachers, and they might not be aware of such apps. So we had to come up with various technology tutorials first of all. And then once the teachers were comfortable getting onto these conference platforms and everything, so we started off introducing our solutions online. Now again, here also there are a lot of challenges. As I mentioned, touch and feel was not there, and all the solutions that we had designed for a school setting did not work here, because children were uh, at their homes. So especially with the computational thinking project that we are doing with Microsoft Research, for the games we had to think of online version of the games. And we also thought about involving their families along with the children during the sessions that we conduct, because some sighted person who will be around can help. And first initially I felt, okay, many children may not have this support, but uh, the parents also got interested gradually, and things are working out fine. And we use things that are available at home itself. For example, we play pebble games. We just use everything that is available at home in the kitchen. So nothing costly, everything that can be easily availed. We are managing with these, and we have, for each and every game that we had offline, we have come up with versions online. And I think these sessions are going on really well, and teachers and parents and everyone's enjoying.
Thank you, Vidya. There's one question in the chat from Swarup Joshi, Bits Pilani. What are some key reasons for relatively low enrollment of persons with disabilities in higher education, especially in STEM in India?
So I really feel higher education is because they're not studying math and science in primary level. As I mentioned, a lot of people are dropping off math and science even before they reach high school because of all the problems that I mentioned. So naturally, when you have not even done math and science till 12th grade, then options are simply ruled out for higher education. That may be the one of the reasons, and we need to start from school level, and only when the children are equipped to do math and science in the school level, they will be able to carry it on further. And some of the people also prefer going abroad because the facilities are available abroad, and they'd rather take advantage of those. And some people have done that. And a lot of people who are visually impaired since birth are finding it really difficult to comprehend what even a simple diagram becomes really hard to comprehend unless your visual memory is stimulated through tactile diagrams or other sensorial inputs. The same kind of visual memory should be built in by the time they reach high school or college, so that they can continue these subjects even beyond. So providing tactile inputs from very early on is really necessary to make this happen.
Good evening, ma'am. I have a question.
Yes.
As you hinted out, just embossing the diagrams in textbook won't be the solution. So, what, according to you, could be the possible solution when it comes to diagrams, especially complex diagrams in biology, etc.?
So right now, what we are doing is wherever possible, we are having, as you mentioned, one of the solution that we have is we are embossing the diagrams into the books itself. So whatever 2D image can be printed in Braille, we are taking advantage of that. But as you also rightly mentioned, that won't be the only solution. We need a 3D representation, 3D models wherever is needed. Because for me, suppose I touch my face, then I get a proper concept than just touching the 2D image of a human face. I really need to see the 3D image as well, 3D model as well as 2D image, at least till I get the concept of that particular diagram. So using whatever is available, the 2D image or even 3D models wherever necessary is really helpful to develop that kind of visual memory.
Thank you. One last question, Vidya. Which software helped you the most while you were studying computer science? Question from Anupama Thomas.
While I was studying computer science, software that helped me is, yeah, definitely I would say screen reader, because it reads out everything that comes on my screen. But it had its own limitations. But talking about one helpful software, I feel that was helpful because at that time screen readers could not read equations and everything that were available. But for most of my tasks, I used my screen reader, and that was really helpful.
Thank you, Vidya. There are some more questions, but let's move on to the next talk, and we will come back after Professor Sylvia's talk and have you both answer some of the questions. Thank you very much, Vidya.
Thank you.
And now welcome Professor Sylvia Fajardo Flores. She is an associate professor at the University of Colima, Mexico, and her expertise is in the broad areas of human-computer interaction, digital accessibility, and educational technology for inclusion. And she has been working in the area of digital accessibility since 2006, adapting educational material for blind students and evaluating web accessibility, and research about non-visual access to mathematical contents for blind users, and improving access for people with visual and motor disabilities. And more recently, she started research to support literacy development in deaf people. She has a PhD in computer science from University of Paris, and she is also a member of the ACM SIGCHI Accessibility Committee. Welcome, Sylvia, and over to you. Please go ahead and share your screen, and look forward to your talk.
Thank you very much. Thank you for the invitation. It was great to hear Vidya's experience. And as you will notice from my talk, there are a lot of things that are similar between, amongst the needs of people with disabilities. I would like to share my screen just to show some slides, mostly for me, so that I can guide my presentation. So yes, I will be talking about the use of assistive technology in Mexico, but not only in Mexico, also in Latin America, since we share not just a language, but also the culture. And most of the situation and context of people with different disabilities. So just to give you an idea of the population population with disability in Mexico. Mexico is the second country with the largest population in Latin America. We have a total population of 129 million people, of which roughly 5% have some kind of disability, which is equivalent to more than 6 million people. And the disabilities, of course, are distributed in visual impairment, hearing impairment, cognitive impairment. And according to the reports, the most prevalent disability was lower limb disability with 48%. Anyway, we have a large disabled population, of course, maybe compared to Brazil or to India, which are bigger countries. This number will be less, but we have our own issues. I'm going to talk about the access to assistive technologies, but I was thinking, okay, we Mexico, we and Latin America, we have some degree of access to assistive technologies, but actually, like Vidya mentioned, there are, let's say, more important or urgent aspects to consider for people with disability. For example, disabled population is practically invisible in Mexico and Latin America. We know from the reports that there are millions of people with disability, but for example, we rarely see them in schools. We rarely see them working in different areas, and that is because they have their inclusion into schools is very low, is very poor. Sometimes even not just people in general, but even their parents are not aware of all the things that their children with disabilities can do, and they prefer to, they decide just to keep them at home or just to send them to elementary school, and many of them, they don't continue their studies because there is no support from their parents sometimes, and of course from the government either. So all this causes to have a lack of exposure to assistive technologies. Mostly we are consumers of technologies. In Mexico, there are very few shops for accessible technology, and most of it is very expensive. It's out of the reach of people, and it's mostly bought by the government through the Ministry of Education, for example, and by some local associations for the disabled. So we're mostly consumers of the technology. And of course, the government does have some laws that are supposed to cover the needs for people with disabilities, but these laws are just, they look great on paper, but the reality is actually very different. The government doesn't have enough funding for people with disabilities, not just for assistive technologies, but in general for their integration into education and society. So that's why I was saying that we have more urgent problems, not just the access to technology, but all the different integration needs of people with different disabilities. So basically what I'm going to show you, maybe these are things that you already know, the kind of assistive technology that we use in Latin America is no different from the one that is available maybe worldwide, but we don't have so much access to them. Like I mentioned, it is mainly through the Ministry of Education, and it centers for the support of students with disability, that people with disability have access to this technology. They provide, let's say, the accessible materials for children in elementary schools, but after high school, they don't have any organization that provides any kind of support for their education. So they, in their reports that I could find online and by talking with people working in this kind of organizations, they told me that they use these kind of devices. For example, for hand motor disability, hand motor impairment, they use a Panda mouse, keyboard switches, and the Ad mouse, which are, used throughout Latin America. I'm sorry, throughout Latin America. For example, talking specifically about embossers, which are widely needed, let's say in Mexico, is very rare. It's very uncommon that someone has it at home. They are basically found in these centers for the support of students, or in local associations, which sometimes get some funding from the government or from the general public or from some donations. And that's how they can get this kind of technology. Also, some universities and libraries have some software. Basically, it's just software like screen readers and magnifiers and other type of applications, mainly for people with blindness. But fortunately, the smartphone use is growing all over Latin America, and that's why people with disabilities have more possibilities of accessing contents, and therefore of accessing education, and later on the workforce. But basically, these technologies are used everywhere in Latin America. Now, let me just mention some of the things that they use. I already mentioned the screen readers for visual impairment, the magnifiers, and the Braille embossers. Braille continues to be the preferred format to access information in Mexico and in general in Latin America. And it's followed by audio and large print. And there are some applications that are well known in the visual impaired population in Latin America, like ID Pro, which I just noticed, I didn't know that is an Indian development, and also some local developments like Lazarillo GPS. So that is for the visual impairment. For the hand motor impairment, I already mentioned the keyboard switches and adaptive keyboards. And some people use eye tracking devices, but actually I don't know many people who use this kind of devices. What is being used by most people with hand motor impairment are the voice interfaces. Most of them use their phones, the voice commands on their phones to access applications. And other assistive technologies that they use are, for example, augmentative and alternative communication devices, which can be available in the form of physical, like hardware devices, but they can also be applications on the mobile phone or on tablets, to enhance communications. But as you may have noticed, I haven't mentioned anything for people who are deaf, because I couldn't find any. I mean, I know that for them, the main language, their main language is sign language. And I think it's awesome that you have sign language interpreters in this event. In Mexico and Latin America, interpreters are very, very few. I mean, there are not many, and they don't usually participate in events, so that deaf people have access to this kind of information. For them, mostly the only accessibility consideration that is made is the captions. However, I don't know what the situation is in India, but in Mexico and in Latin America, the reading comprehension of Spanish languages of the Spanish language is very poor. And I mean, of course, it's a second language. Learning a second language already has its difficulties. But another, I think, more serious problem is that deaf people have not had enough exposure to the Spanish language, the written Spanish language. And that is one of the main consequences for not being able to read in Spanish. So captions, of course, they're better than nothing. It's better to have captions, but definitely it shouldn't be assumed that people with deafness are going to understand what they are reading. So I wanted to talk about very briefly about some of the local developments in Mexico and other countries in Latin America. There are not many, okay? I will just mention a few. Like I mentioned, mostly we consume the technology that already exists. But in Mexico, we can find this for the visually impaired. For visually impaired people, we have this bracelet, which is called the Sunu band. It's a commercial product already. It detects the objects up to 5.5 meters away. Like it works like a sonar, and it informs the distance to the obstacles using haptic vibration. According to their creators, it's being used by more than 5,000 people in more than 45 countries. Personally, I have never seen this product being used by people with deafness, but I don't know. There must be people who use it. And another local development that I found was a brain-computer interface for neuro rehab from the National Institute for Rehabilitation. But I couldn't find, I found this in some reports and some documentation, but I couldn't find any actual image, let's say, of this interface. I don't know what it is about. And that's all that I could, that I can mention about developments in Mexico. In Colombia, I found that they don't actually have any local developments. I mean, at least I couldn't find any. It doesn't mean that they don't have any. But I found that in their country, the government provides access to the screen reader like JAWS, and they bought some licenses for JAWS and the Magic Magnifier, and their availability is in libraries and in electronic kiosk where people can go and look for some services, for some government services available online. And also they have local organizations. There is this one called Ayudas para Todos, which means support for all, which provides some tips for accessing low-cost assistive technologies. And I'm not talking about electronic devices or things like that, but to more basic products such as the slates. The slates for writing Braille, they are difficult to find in Colombia, according to this organization. So they provide some low-cost 3D printing of slates from the models that they find on the internet. So as you notice, it's we're not even talking about access to technological devices, but to more basic devices which are not available for people with disabilities. That was in Colombia. In Brazil, they do have, I mean, apart from using the technologies that I already mentioned, they do have a local development. It's a software called Hand Talk, which is an avatar that converts voice and text also into the Brazilian Sign Language, which is called Libras. This avatar can be used on mobile phones and on web, on computers. And it's called Hugo, the character is called Hugo. And Hugo will translate from the Brazilian language to the Brazilian Sign Language. And I think that this is a great development, but actually talking with people who work with deaf people, other people who work with deaf people, I noticed that not all of them are so excited about this kind of development. But anyway, this is something that has been developed in Brazil for deaf people. And then in Chile, we have this application, which is like a GPS. It's called Lazarillo GPS, which provides non-visual navigation to basic places, for example, to hospitals, to restaurants, to banks or museums. And it provides detailed descriptions of the public transport. That is why this last bit about the public transport is also used actually for people, not just blind people, but also for people who use a wheelchair in order to find accessible routes. Because I don't know what the situation is in your country, but in most countries in Latin America, the roads are not accessible to people using wheelchairs. So it's important for them to find the routes that will be accessible for them to reach to different places. This application has more than 160,000 users across Latin America. It's a well-known application, and people in Mexico also use it. So that is in Chile. So I would like to mention quickly some research and development opportunities. And of course, I think that, like I mentioned before, our collaboration shouldn't be just in developing the accessible technologies, but also in ways of supporting the integration of people with disabilities in schools, mainly in schools and in society in general, so that they become more visible and so that people know that the type of disability that they have does not prevent them from studying, does not prevent them from working in different areas, even in like they mentioned before in areas of science and technologies. And it doesn't mean that the works that they do now are not honorable, of course, but many of the people who are doing, for example, jobs in cleaning or driving, they really want to study, and but they don't have enough access. So this goes without saying, we need low-cost assistive technology because of the lack of funding. And but not only that, also I think that more research and development is needed for people with multiple disabilities. Like right now, there are applications and devices for people who are blind, or for people who have hand motor impairment. But what about people who have both impairments? I know some people who are blind and have a motor disability, and you have no idea of how difficult it is for them to access contents, even to use their mobile phones or computers. It's really difficult because the usual accessible adjustments in the configuration of smartphones, they don't consider that people can have both disabilities. For example, if you are blind, you can use a screen reader, but you need to use your hands in order to interact. But people with hand motor impairment might not be able to do these gestures, might not be able to even to hold the phone. So for them, of course, the voice interfaces are the most appropriate. But anyway, what I mean is that more research, more development is needed for people who have multiple disabilities. And also, in order to improve the communication between people with and without hearing impairment, because we use different communication codes or different languages, basically. And lastly, I would like to say that it's important to work with people with disabilities and not just for them. Because in the area of technology, if we don't work closely with people with disabilities, we may have good intentions. I'm sure people with this, working in technology have good intentions in providing assistive technologies for people with disabilities. But if we don't work with them, if we don't get to know their needs and their characteristics closely, we will not provide adequate solutions. And I have seen this. Some people who work in technology, they think it's a great idea, to provide this kind of assistive technology for people with disability, but people with disability are not able to use it, or they openly reject it. And that is why I think that a close collaboration is needed, not just amongst researchers from the Global South, but also a complete, a higher inclusion of people with different disabilities in the technology-related development. And I would like to close with that. Thank you very much.
Very much, Sylvia. I have one question before we open for the audience. In India, for example, children who are blind, vast majority of them who go to schools for the blind. Very few attend integrated schools. So how is it in Mexico? Are there special schools, or is the majority going to integrated schools?
They're both. They are both. They can go, for example, blind people can go to schools for the blind, but actually the characteristics of these schools is that they are not particular of one single disability. For example, there are schools where they are students who are blind and who are deaf and who have different kind of disabilities, and the attention is not necessarily particular to the kind of disability that they have, but they attend, on one side, they attend special schools. But actually the government, for many years, the government has tried to include students with disabilities into the mainstream schools. This has been only partially successful because, for example, a blind student attending elementary school, they are able to communicate, they are able to move around the schools and to socialize with their classmates, but usually their study materials, they arrive late. For example, everyone gets their textbooks at the beginning of the school year, but the children who are blind, they don't get it at the same time. They get it, I don't know, 3 months, even 6 months later. So they don't have the material to study. Fortunately, the technologies can provide good assistance in this matter. So they have both. Now, for children who are deaf, the situation is a lot more complicated. They actually have to go to schools for for the deaf, but these schools do not provide formal education because they have several different grades in one single classroom, and they sometimes, when they go to school, there are children and teenagers and adults also, even adults who are already working. They go to school, but just to learn Spanish, to learn how to read and write in Spanish. And so their education is not formal. And for the people, the deaf children who are integrated in schools or included in schools, the situation is even more difficult because, first of all, they suffer rejection in schools. They go, like the parents go with their kids and they talk to the principals of the school, and the principal says, no, we don't have sign language interpreters. We don't have, we cannot provide for your kid. Even though there are these centers for the, what are they called? Which provide materials for people with different disabilities, for deaf people, it's very difficult to integrate them. I remember I read something, I liked it very much. And it said, we are talking about inclusion of deaf students in mainstream schools, but what is more inclusive? To have someone who is deaf in an environment of speaking people and not providing for their needs, like who are not able to communicate with them, or just to socialize with other deaf people in special education. So what's more inclusive?
I think
We're not
this
there
is,
yet. We're not there yet.
Yeah, I think I have, I think Professor Balakrishnan had a question. Bala, please go ahead.
Yeah, so in terms of the visually impaired children, how popular is Braille? Do the blind schools teach Braille? That's one. And along with it is a question, how much access to tactile material is there for the blind children?
Mm-hmm.
Diagrams.
Braille is still widely used. I mean, embossing is still needed in schools, especially in elementary schools. I mean, I know that blind people use screen readers on their smartphones or on the computer, but Braille is still the main like the preferred format for accessing information. So Braille is going to continue to be. In tactile displays, we don't, I mean, people in Mexico and in general in Latin America do not really have access to that kind of technology. For example, I know that there are—
I'm talking about tactile diagrams.
Tactile diagrams. Yes, some of these centers that I mentioned from the Ministry of Education, they have embossing machines for tactile diagrams and maps. They do use this kind of technology, but there is like one for example, in Colima state, in Mexico, there are 31 states. Colima is one of the smallest. Maybe there are 1 or 2 of these machines to provide for all the state.
Yeah. Thank you.
I don't know if I answered your question.
Yes, yes.
Yeah, I think Bala, I think you should probably connect offline because Professor Balakrishnan has a startup which has now grown called Race Line Foundation, which is doing immensely wonderful work in providing tactile diagrams in a way that you give a textbook to a blind child, which is Braille usually. Just give them the Braille. They've been able to do is bring down the cost of printing tactile material, that now blind children are getting textbooks which have all the figures and diagrams and tactile diagrams in place. That's a remarkable change over the last several years, and I'm sure it will be great for you to connect Bala with the.
So we will send you some samples and get back to you.
It will be very, very useful. I think there are many opportunities, I think, for building bridges, and look forward to interacting with you, Sylvia, beyond the conference. This is just the beginning. And so thank you so much for being with us. We will, I think if there are any other questions, we can have one more question if anyone has. Otherwise, I think we need to move to the paper presentation session. Thank you so much, Sylvia. All right. So we have 2 short papers in the session. The first short paper is designing a tactile display for Braille and non-Braille users. This is by Anupama Thomas and Elizabeth Rufus. I think Anupama is here. The timing is 10 minutes. Please restrict yourself to 10 so that we can keep the time. And the audience, please type in your questions in the chat, and I will forward it as appropriate. Go ahead, Anupama. Please go ahead.
Thank you. Can you see my screen?
Just coming up. Yes. It is in the slides mode. It is not yet in the presentation.
Yeah.
Yes.
So good evening, everyone, and I'm going to present my work on designing a tactile display for Braille and non-Braille users. So this work was done in BIT and continues now in IIT Madras. So this is very familiar that Braille is a code for blind, and figure 1 and 2 shows the pattern of raised or lowered dots which depict the English alphabet here. Figure 3 also shows different raised fonts that were used as early as in the 1800s. And out of these raised fonts, these were for people who didn't know Braille. The Moon's type was the most common. So when we design a tactile display, the two features we must keep in mind is that there is a sliding movement between the text and the reading finger. And there is also active hand movement that occurs as text is read. And depending on whether the person is an early reader or a mid-level learner, they use maybe a single finger or many fingers to run over letters. So how does a person access information from the computer? What is most commonly used are screen readers. And then they have tactile displays, but the high cost, as we see in figure 5, 36 lakhs. Braille Me in India with a 20-cell single line displays, 43,000. Perhaps the high cost of these Braille displays prevent people from learning Braille. In fact, percentage-wise, they say that only 10% of children actually are learning Braille, and this can be due to the high cost of Braille displays. Now, this is a tactile display that was very commonly used. This is for people who did not know Braille. This was the Opticon, where printed text was converted to a vibrating tactile image. It was widely used, but was discontinued because of company issues. So the objectives of our design were that the design should allow a sliding movement between the finger pad of the user and the text to increase accuracy. And we wanted it to be adaptable for use by non-braille users also. And there was a need to make it cost-effective, using the minimum number of actuators. So in our design, we just used a single actuator, and we had detachable embossed discs. So we had a Braille embossed disc for people who knew Braille, and for those who didn't, we had the lined letter or the dotted letter to see which was more tangible for users. So in our Braille embossed disc, after many iterations, we put 13 characters embossed around the circumference of the disc at every 28.8 degrees. The thickness of the disc was 10 millimeters so that they could place their reading finger comfortably. And the dot extrusion was taken as 1 mm, which is just 0.1 mm higher than standard Braille specifications, because that was required by the 3D printer. Now for the lined letter disc, we embossed again English characters along the circumference, but we chose uppercase as literature said that uppercase was more tangible than lowercase. We chose a letter size of 9 mm because again, literature said that letters between the size of 8 mm to 11 mm were tangible. So again, we used the font Calibri size 34 to emboss lined letters on the disc. Similarly, we had a dotted letter disc, and we maintained the 2-point discrimination threshold of 2 to 4 mm on the fingertip in the design of the letters. And here again, they were extruded by 1 millimeter. So this is what our prototype looked like. We had the electronics housed within the enclosure so that the user could place their hand on it comfortably while a reading finger was placed on the rotating disc. Now, these are the specifications of a prototype in comparison to what is generally required of Braille displays. We were able to maintain most of the Braille dot dimensions, except maybe the letter height, which was 1 mm as required by the 3D printer. Now, the refresh frequency refers to how fast letters come up beneath the user's finger. And they say 1 Hertz is needed for most, 10 Hertz is needed for most applications. Well, 1 Hertz can be used for applications with less interactions. So our design introduced varying refresh rates between 2 Hertz to 32 Hertz. And the weight of each disc was about 12 grams. The weight of the enclosure without the disc was 312 grams. So what would it take to read with our design? So if you look at this word hook, between the appearance of H and O, it took 32 milliseconds. Between O and O, that is a full rotation of the disc, bringing the disc, the letter O, right back underneath the user's finger. It was 400 milliseconds. Between O and K was again 128 milliseconds. So our question was, would readers be able to read accurately with these varying refresh rates? And the second question was, between the appearance of H and O beneath the user's finger, there were other letters that brushed past the reading finger. We call them nonsensical letters. Now, would these nonsensical letters hinder reading accurately? So there were two questions here. And if it didn't work out, we'd have to scrap the design. So here was our evaluation with participants who were blind Braille participants. We had 17 participants, and we sent them 24 words were given as 2-letter, 3-letter, 4-letter, 5-letter words presented in 2 sessions. And here we use the Braille embossed disc. And we compared their reading with similar words printed on paper Braille. So the comparison is how they read on paper Braille versus how they read on a prototype. The parameters we measured were the accuracy, that is a percentage of correct responses, and we looked at their session speed. These are the results of accuracy with our 17 blind Braille participants. And here in an easier format, we had a percentage accuracy of 96.15 on paper Braille, and with session 2 of the prototype, it was 98.62. And the outcome of our results showed that accuracy of reading with varying refresh rates was similar to that of reading on paper Braille when we did a paired t-test, indicating that varying refresh rates and the passing of nonsensical letters beneath the finger pad did not impede reading. So this suggested that our design was feasible. We moved on to testing with blindfolded sighted users and blind non-Braille participants. And both these groups retain a visual memory of the alphabet, whereas blind non-Braille participants have an added advantage of increased tactile experience. So over here, we had the training protocol included a training session because they were not used to reading by touch. Some of them are just used to screen readers, and the blindfolded sighted Peter had very limited tactile experience. So in this evaluation, we had a training session, and we used the lined and dotted embossed discs. The parameters we measured here were how many training sessions were needed, the percentage accuracy in reading words, and their session speed. So these are our results with our 10 blindfolded sighted participants. Using both the disc, the dotted disc and the line disc, we wanted to see if there was a difference in perception. And here for the blindfolded sighted participants, they took 1 to 2 sessions and they achieved a word accuracy of 90%. Similar for both the dotted disc and the line disc. We moved on to, so what was the outcome of our evaluation with them? The accuracy was high at 90%. When we compared this to previous literature, we found that there was a decrease in training time for tactile reading from 9 months in this paper by Bola et al. To 20 minutes for blindfolded sighted participants to achieve a tactile reading speed of 6 to 7 words per minute. So there was a decrease in training time because we banked on their visual imagery, the memory that they have. Then we moved on to testing with 12 blind non-Braille participants. Again, the number of training sessions and how they read on the dotted disc and the line disc. And here they just needed 1 session because of their increased tactile experience. Their word accuracy for both of them was over, using the dotted disc and the line disc was over 96%. And what was our outcome? The accuracy was high, the training time further reduced to a single session, and there was no significant difference when using both the discs, so either disc could be used in the prototype. So in case people are wondering what words were presented, these are the words that could be presented with a few characters that were embossed on the disc. And this is the cost involved in the prototype. So this is like, it can be modified for late blind or for early blind who know Braille and the late blind who do not know Braille. Our cost for the prototype was 4,716. The full paper is available at Technology and Disability. And this work was funded previously in VIT and currently now in IIT Madras by the Department of Science and Technology, Government of India. I want to thank you for your time.
Thank you, Anupama. I think in interest of time, let the questions be on chat. I will put a question in the chat. Let's move to the second talk, which is the paper on empowering persons with special needs during examinations by Sanjay Mukherjee and Chardatta Yadav. Request to the attendees, please type in your questions on chat, and I request the authors to respond to chat as you can. Thank you so much. Over to you, Sanjay or Chardatta.
Good evening, Manoj sir. Good evening, everyone. Good evening, the organizers, the participants, the panelists, the speakers. Thank you so much for this opportunity. Am I audible? And
Yes.
I'm unable to share the screen. So
I think Anupama needs to,
yeah, thank you so much. Thank you. Thank you. So I'll just share my screen. Do let me know once it's
yes,
you're able to see it.
Coming up, and
yes.
yes, you can see it. Please go ahead.
Okay. So oh, sorry, hold on. Just a moment. Sorry for the delay. It's up now. So thank you so much once again for the opportunity. The topic on which I would like to take a few moments of everyone is empowering persons with special needs during examinations. The reason why I picked up this topic and what we are doing, I come from TCS and TCS ION, which is a strategic business unit of TCS. We are primarily providing cloud-based solutions to the industry, SMB, the small business units, or manufacturing, and also education. I'm from the education wing. I'm actually managing the school education business. TCS is known as the largest, high-stake examination enabler. And we conduct, round-the-year examinations, be it CAT, be it JIPMER, be it any banking services, be it anything. So as of today, while I'm talking, we have already assessed about 140 million candidates till date. Across various centers. We are present in more than in all the districts of the country. However, while we have been doing this, we always are looking at how we can create an impact in the society. And we have been observing over last so many years that when we talk about examinations, only students are coming into our test centers, giving the examinations and going back. But we have seen very little presence, or practically no presence of our candidates who are children with special needs. Particularly, when we talk about the 21 different categories which has been categorized as per the RPWD Act. We wanted to look at how we could enable and how we could make ourselves as an inclusive assessment enabler, and hence this led us to be discussing with various institutions, with various directly impacted candidates, also the families of such children, that what are the typical challenges that a candidate faces when they sit in any kind of a high-stake examinations, and what are the challenges that the institutions are facing when they have to actually allow such CWSN to sit in a kind of an examination. So this solution that we are discussing today, it's primarily for the institutions, for examination boards and higher education to empower and enable children with special needs. Particularly, we have piloted and tested it for deaf and hard of hearing, and also for visual impaired candidates. So when we were actually talking with various doing our surveys, doing the research with the institutions and also such candidates, one of the major challenge which was actually highlighted by such children and also their parents was, the first thing is that the moment a date sheet is declared, the challenge starts from that particular day for the child and for the family, for arranging a scribe or an interpreter for their child, who is going to appear in, say, 5 or 6 different exams, for 5 or 6 different papers in this exam cycle. Now, one is identifying, second is working with that scribe and interpreter. The third is ensuring that that scribe or the interpreter is available on all those exam days. So it's a kind of a humongous challenge which children and also their families have been facing. And most of the time what happens is the child actually loses out on that exam day when the interpreter or the scribe is not available. Now, while the institutions also provide the interpreter on that exam day, but there is always a kind of a comfort level which creeps up when you have practiced with a specific interpreter or a scribe while preparing for the examinations. So there's multifold challenges which we could analyze basis the discussions with various the stakeholders. So these are some of, so not only the child has to register himself or herself for the examination, they also need to register the scribe or the interpreter during that examination. The hall ticket also has the details of the scribe and the interpreter. So assuming a situation wherein the child reaches the examination center, but the interpreter or the scribe is not there. So it's a kind of a chaotic situation, which many of the the interviewed families have shared with us, and institution, and they know I'm looking at how it's performed, because here there's always this thing comes up wherein whether the interpretation of the question has been right or wrong, and whether the response that has been submitted is right or wrong. This also is a question which the interviewed children have shared. Okay, so these are some of the major challenges which were actually back of our this thing when we started looking at how we could enable such children. Now, on top of this, the second aspect that we also looked at is that there are, if you look at the demography, if you look at the geography, the widespread, they're across many centers there in tier 2 cities, tier 3 cities, tier 4, tier 3 cities and all. Creating an infrastructure, kind of an infrastructure for, as and when availability of such children for coming and taking the exam is an issue. So we also had to look at how we could create on-the-go infrastructure when when an examination is being conducted and the examination body says that, okay, we are going to have 5,000 CWSN children who are going to sit in exams across 734 districts. So ramping up the infrastructure was also one of the things that we actually looked into. Now, I'm just sharing this thing wherein the technology, why we actually use this for, in conducting such examination for CWSN. The very important thing is that if you look at, so many tablets which are lying there, these are TCS ion paper device. These are being used for conducting high-stake examinations. These are being used for distributing question papers on the go. The very important thing is that this, during the course of the examination of 3.5 hours, this does not have any internet connectivity. The internet connectivity is required only at the time of downloading the question paper and uploading the response. Okay, so this is kind of a business as usual, which we have been doing. So the objective was that, how we could make it more robust and powerful to enable a deaf or a hard of hearing child, okay, to independently sit in an examination without being dependent on any third person. Now, this was actually, tried with the Deaf Society. It's a renowned Deaf Society, Noida Deaf Society, all of you would know. And we conducted a mock assessment with their deaf students. And this is what was the feedback that we received from them, was that this is a kind of a technology which help them, reducing the kind of time that goes in for doing a kind of a face-to-face assessment of a deaf child. Now, wherein the testimonial itself says that if they have to do an assessment, they have got so many hundreds of students who are there, and if they have to do an assessment of the students, then the instructor, who themselves are deaf and hard of hearing, they have to do a kind of a face-to-face, interaction with the candidates and with the examination system. So this actually
Sanjay,
has...
Sanjay, sorry to
Yeah.
interrupt. I think you are maybe 2 more minutes. If you can wrap up, that'd be great.
Yeah, I'm through. This is the last slide that I had for you.
Excellent. Thank you. Thank you.
Thank you so much. So if you, I'm through. So if
Excellent.
you have got any questions, then I'm free to go.
So my question is, you've done some trials, but have you, what exam level are you targeting for the hard of hearing individuals?
So the exam level, come again, sorry.
Which exam are you specifically targeting? If at all you are going to pilot, what is the first actual exam you will use this for?
So we have already piloted this with Deaf Society. We have already piloted with an open school institution in India. And the solution, we are using this for conducting all assessments. Okay, so whether it is, a pen paper, whether it is, the question papers are no more printed by us. The question papers are handed over as a tablet, which is given to each and every candidate, and they see through the question paper and write on a response sheet. That response sheet gets scanned by us using the same tablet, and it's uploaded onto the cloud. That's one. Second thing is that
sorry, my question is not clear. I was asking what actual exam are you targeting first to run it in a real exam? Which exam are you targeting? Because these pilots are good to prove that it works, but which exam are you targeting?
Oh, well, so that is still in this discussion with the institution. So most probably what they're going to do is that they're going to, during their board examinations, they're going to be using this solution on a trial basis primarily for, their CWSN candidates, those who are hard of hearing and also those who are visually impaired.
Thank you. Are there any questions? All right. So thank you very much for the presenters. And again, thanks very much to Vidya and Sylvia. There's one last question maybe for the session and the day. It's a long day. So Ashutosh, can you make a brief question, please?
Okay. Sorry, I don't have a brief question. I am Ashutosh Singhal. I am late blind. Could you please tell me what does your device do?
Yes, Ashutosh, I'll surely do that. So what this paper, iron paper, is primarily for exam conduction that we are currently using. This also is being used for learning purpose, both online and offline learning. And this device enables institutions to conduct both online exams and also offline exams, even OMR based exams, and even audio based questions are being done with the audio based response also getting submitted, and also video based questions with a video based response submission capability.
How can I connect from you after this session, Nyai?
Well, in fact, we are actually working with the institutions, Ashutosh. So this is primarily for the institutions and also the examination boards. At the moment, what definitely we can discuss is that how we can have a kind of a trial with you as well separately. You can connect with me on my phone, and we can discuss this further.
Please give me your phone number, contact, mobile number.
I'll
Please share on chat the email ID. Maybe that will be useful to start with. And so thank you very much for everyone's participation. I hand it back to Amit. Over to you.
Thank you so much, Mr. Manohar. Thank you so much, everyone.
Thank you, Dr. Manohar. Thank you all the speakers, Sylvia with their both the two paper presenters. Thank you very much. I know this is quite late here, quite early for you, Dr. Manohar and Sylvia, but it has been a good day, productive day, I would say. Very interesting presentations all through the sessions. Thank you everyone for staying back. We hope to see you again tomorrow morning at 9:30 a.m. And again, we have very interesting sessions lined up tomorrow. Thank you very much. Thank you, Vanshika. Thank you, Preeti, for signing.